Hey guys, CWHolo1 here. Welcome back to another video, and today we're here with Lionel 2-11558. This is a CSX SD80MAC, and today we're going to be putting Blunami in it. Okay, so before I get into all this, what is this thing? This is a conventional only SD80MAC made by K-Line, and I think it was made by K-Line like during the period where Lionel was buying them or buying the rights to have their name or whatever. So it comes in a Lionel box. It's the only 2- number I've ever seen on a locomotive, and it's got a big K-Line stamp underneath the fuel tank. Now, this engine has the K-Line cruise control electronics, which sort of work and honestly are very similar in architecture to the modern legacy engines, at least in the way that they do the encoders and stuff for the motor feedback, but this one doesn't really run great. So this engine, when you first start it out, doesn't want to move at all, and then as you run it more and more, it gets better and better until it finally decides that it wants to operate like it should, fresh out of the gate, and then you have pretty much normal operation from there, or as normal as you can get for conventional. So this engine also has a really crappy sound system. Now, in the original video where I featured this engine, Sid from Sid's Trains actually commented to give me a little bit of backstory on the K-Line electronics that are in this thing, and basically gave me a very simple explanation for why this board doesn't work, and that it's just that it sucks because it's old and they blow up. So when K-Line boards start to go bad, they just do all sorts of wacky stuff, and apparently this is one of the things that can happen. So, going along with the Sid's Trains theme, he is doing some incredible work pioneering Blunami, which is a DCC decoder made by Soundtrax that is equipped with a Bluetooth module, I guess, that allows it to talk to your phone. And basically what that means is that without any additional electronics or control systems, we can run a DCC engine with all the advantages of DCC, such as, all the motor control and all the sound options and all of that, using our phone on 3-rail track with AC power. So he's been doing some incredible stuff figuring out how to make everything work and how to include smoke units. He's got whistle steam on a couple engines that he uses, or that he's got Blunami in. Absolutely incredible stuff. Highly recommend you go check it out if you are interested in anything that I am talking about here and somehow aren't familiar with the work that he has already done. So, with that, let's get started by going through all the parts that I got for this thing. Okay, so first, let's take a look at our Blunami board. So this thing's actually way smaller than I thought it was going to be. For comparison, actually, here is a electric railroad. This is the AC Commander, but the Cruise Commander is the same size. And it is pretty much the same footprint, except this is obviously way lower profile, and this has sounds in it as well instead of just motor control. So that's pretty cool. Also, I think I have an idea for that DCDR, but more to come on that later. Yeah, so that's the board. That's the expensive piece of the puzzle. It's a $200 board. But when you compare that to, what is it, like $250 to $300 or something like that for an electric railroad, Cruise Commander and the Sound Commander, you're just getting a better deal. You also need these. These are gigantic capacitors. When I ordered them from DigiKey, I looked up the dimensioning and whatnot. I was like, yeah, that seems fine. It's the smallest ones that I can find that are, 1,000 microfarad. And yeah, so they're big. But these are, where's the part number for this? 4931623ND from DigiKey, and these are pretty cheap. So I got 4 of them because I also have parts for a friend who's also doing a Blunami install in a SW8 or SW9 switcher that got fried in one of his operating sessions. I what actually is this? Oh, these are the rectifiers. Duh. So in order to make this work, you have Blunami board needs a DC input. It's just how that works. Obviously, we have AC going to our track. So to convert the AC into DC for the Blunami board, you use a rectifier, which I'll get more into that a little bit later. I might even hook up my oscilloscope and show you what I'm talking about. I also have speakers, because the speakers that are in this are 16 ohm half-watt speakers, and the sound driver on the Blunami board is an 8 ohm, oh boy, 3 watt sound driver, I think. You can see the specs on their website. And then I have a bunch of buck converters, which is what these are called. These are basically constant voltage converters for DC power. So they take DC in at pretty much any voltage and output a constant voltage from that. So very cool. Lots of parts. And I also need to fabricate some brackets and figure out how I'm going to be doing lighting, because the lighting in this engine is sort of weird. But let me take the shell off and I can show you guys what I'm talking about. Alright, here are the internals. It does actually have a smoke unit, which is neat. I think it just runs flat out all the time, so not super complicated. Diesels also don't really create smoke in real life, and my friend doesn't really run smoke to begin with, so that's probably not going to be staying in there, but I'll talk to him about it. So yeah, this is his engine. This is not mine. So yeah, big tall motor, big tall motor. This has a huge flywheel on it, which I find amusing. This one has a little flywheel, but it has the same optical encoder that isn't going to want to focus. There you go. That modern legacy engines have. So that's pretty cool. And yeah, K-line. So I'm pretty sure Lionel reused the K-line tooling. Man, this thing is, I need to fix some of these details. Lionel probably reused the K-line tooling at some point, because K-line made some really well detailed models. But yeah, so motor control board, which you could replace with a Cruise Commander M from Electric Railroad. That's $160 as opposed to the $200 Blunami board, or it's $250 from Soundtracks. You can find them for like $200. And then this is the soundboard here. So if you use the Cruise Commander M, I'm not sure how it would do talking to this, but these sounds kind of suck anyway, so we're just getting them out of there. And then the lighting, the original reason I cracked this open, is actually controlled by the motor. There's some circuit boards up in the rear and in the cab that basically just have a bunch of diodes and capacitors and resistors in there to take the motor voltage. Because it's a DC motor, the electricity has to go in one way and out the other, and depending on which side that happens on, determines which way the motor spins. So they use that to basically tell the lights only go on when you see the motor turning this direction, and also filter it a little bit and dim the lights down. So that's what that board does. That's what both of those boards do. Those PCBs probably are just going to get trashed. Well, I say trashed. I'm going to keep them because I'm a hoarder, but they're not going to be staying in this engine. So I'm going to be making some new mounting boards probably that uses the original hardware and the original mounting points in order to mount the new reverse light. It doesn't have rear number boards, and then the headlight. So that's the plan. It also has a whole bunch of switches up top, which I don't know if they're going to get used, but they're probably just going to stay there. Yeah, so without further ado, let's go ahead and basically gut this entire engine, and I need to replace the speakers. So yeah, let's gut the entire thing and then take the fuel tank off so I can swap those speakers out. DigiKey has some very cute packaging for their speakers. It comes with these little round enclosure things. So yeah, anyway, these are the new speakers. These are 8 ohm, I believe they're 1 watt. Doesn't actually say on here, which is kind of neat. Maybe it says it on the packaging. Yep, 1 watt. These are, as far as I can tell, the speakers that are in here are 50 mil. So I got 50 mil speakers. So let's take one of these out and see if I am correct. Because if I'm not, I get the feeling I'm going to be machining the speaker before I'm machining the housing. There's a lot of hardware in here. There's a lot of ways to retain speakers. This is the tried and true screw a washer to the flange, the speaker flange, and it'll stay in place. That's the old speaker. Hey, like a glove. All right. The other problem is that it's not going to seal against this baffle, so I need to cover this hole to prevent the sound from escaping. And I could do that in a couple ways. I could make plugs for it that are carefully measured against the speaker and just slot right in, which is probably what I'm going to end up doing. Or I could just tape it over if I was lazy. But I think I want to try and do this correct because it is not my engine. But yeah, so let me crack this other speaker out. I'm going to transfer the wires over. I do want to try to reuse some of the connectors if possible. The wiring harness that came out of it is just kind of a rat's nest. But yeah, so I'm going to keep working, and I'll see you guys when I see you. So I may have done goofed. We're going to find out when I hook it up to the Blunami board and actually test it. But the way resistors work in parallel versus series, these speakers are basically resistors. So if this was wired in series, which is positive to negative, and out, the resistances add up. So R1 plus R2 plus R3 plus R4, etc., etc., etc. So this would be 16 ohms in series. Resistors in parallel, which is how this is currently configured, which is negative to positive, actually go down in resistance. The formula is 1 over R1 plus 1 over R2 plus 1 over R3, dot, 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 dot. Because I only have two resistors, you can basically just take whatever the resistance is and cut it in half because of the same resistance. So this would be a 4 ohm resistor. That would have been an 8 ohm resistor. So that would have worked with the original board. These are 1 watt speakers, which I believe are theoretically better. It also lets me do a better job of sealing the chamber, which will be nice. But yeah, so this is a 4 ohm speaker. That's an 8 ohm speaker. That's the way the wiring works, because resistances, well, we're going to find out if I blow these up. So you guys are about to get a little taste of my day job, and the name of the game is leakage. So what I had said earlier about taping this off versus making plugs for it, I wanted to make plugs for it. However, if I make a plug for it, there is very little chance that I will make a perfect fit to this hole. It's just mathematically very difficult. And engineering or machining wise, it's very difficult. So additionally, if I had a piece of plastic resting on the speaker that was filling this hole, if the speaker comes loose and at any point starts to rattle, that plastic is going to start vibrating and start rattling against the frame, which doesn't sound great. So that perfect fit matters because of leakage. The idea is you want to seal this chamber as best as you can. So if I created a machined or 3D printed piece here, there's going to be some sort of geometric annulus that you can calculate a discharge coefficient through and find a leakage value of air getting past it, unless I put some sort of seal on this bottom face here. So if I tape this off, because I don't need anything to come through this hole, theoretically ever, if I just tape this off, that leakage is effectively negligible. It's a value. It's probably like 0.0001 pounds per minute or something like that, but it's compared to a geometric annulus, it is negligible. So I think that's just what I'm going to do. It's going to look ghetto, but you're never going to see it because it's going to be pressed up against the bottom of the frame, and I think it'll actually produce better sounds. So that's the plan. I do that at work all the time because valves. And yeah, so I'm going to screw in these speakers, tape off these holes, mount the fuel tank back onto the shell, And at that point, I think we're done everything on the bottom side, and we can start doing the fun part of trying to convert AC to DC. Okay, so I have to do some design work here. I have to figure out how to mount this in here so that it doesn't, fry itself. Everything is accessible, and hopefully I can just reuse one of these original mounting points. But I need to get this printing so that as I'm working on this, that can be underway. So I'm going to try to throw something together real quick in CAD and get that printing. It's probably just going to be some sort of clamp that sort of makes an L here and then comes down to a plate that has the provisions for these holes in it. But I don't know. Let's see what I come up with. So here's our mounting bracket. I'm pretty positive I'm going to have to drill out those holes because I definitely made them a little too small, but this should do. I'm going to test fit it here and see if it actually works, but the design's very minimal. Literally just meant to basically be an adapter plate and give some height. So nothing too complicated. Also, to do the rear lights, I moved it over, so I put a resistor in and I went to the third rail and ground, and those basically directly connected to the lamp outputs that were on the end of that board, because, multi-use stuff. So with a resistor, it's a 1K resistor coming from the board. That should be a pretty nice glow. There are 2 LEDs in there, so it should be somewhat even across the rear light. The bracket for the front lighting is currently printing. I have 2 provisions for the number board LEDs. I've got one for the front headlight, and I've got one for the cab light. So we'll see how that ends up coming out. But for right now, I'm going to try and get this board mounted and go from there. So the 3D printed bracket didn't end up working out too well, so I desoldered every single component on this board, which is the original front lighting mount, and I made this absolute hodgepodge of stuff. But it works. And each of the lighting features now has their own input, so I can't remember exactly which one is which. I made a little diagram when I was originally setting it up, but now the colors are wrong because I redid them. But red is constant voltage in. I believe yellow is class light, or number board, sorry. Black is headlight, and white is cab light. And yeah, the reason that there's this bar that goes over top is because I had to actually cut the trace between the cab light and the number board light because there was a trace that went between the two, and I didn't want that, so I had to cut it apart. Yeah, going from every single light on the front is illuminated at the same time thing to this, not fun, but hopefully absolutely worth it, considering the fact that I can now have Rule 17 lighting and stuff like that. So this can go back in the locomotive. And the last thing that I have to do for lighting are the ditch lights, which I believe are these guys. I have to do I can use a diode check and see if it lights up these front ditch lights, but I only have front ditch lights because it's an SD80, so I don't have to worry about rears. I have no idea how to program ditch lights with the Blunami decoder, but I'm sure I'll figure it out. It's going to be weird for this one because oh no, never mind. I'm going to have to get kind of creative with this and may have to flip some wires around because I would put money on the fact that it uses a constant negative, and I can't do that. I have to switch positive, or I have to switch negative and have constant positive. That might be fun. Okay. Let me take a think and see what I can come up with here. Alrighty. Ditch lights are done. I managed to pull them out, fish the wires through, desolder them, flip the LED, and resolder them. So now black is red and red is black. This is my VCC positive that is fixed from the Blunami board because the Blunami board switches negative. And now the reds are my negative for my left and my right ditch light. So I do need to add a resistor to this wire. And then once that's done, I can, well, I'm pretty much done with the lighting. So that's neat. Motors are going to be next, as well as I need to make the rectifier with the capacitors and then plugging everything into the Blunami board. And then we're pretty much good to test. So it's just all this little fiddly stuff that I want to get out of the way first before I give myself the satisfaction of actually firing this thing up. So I'm going to attach this resistor, but after that, I think I'm going to call it for tonight because it's late and I have to go to work tomorrow. So with that, I will see you guys tomorrow. All right, let's talk rectifiers. That's what this little guy is down here. It's just this little block with 4 tangs coming off of it. Basically what it does is it takes AC in and turns it to DC out. So there are 2 little wave symbols on one end of it. That is your AC hot or ground. Doesn't matter because it's AC. And then there's also a plus and a minus, and that is your DC positive and DC negative output. So I'm going to power up my CW80. I've got it hooked to the AC side right now. So actually I'm going to set this to AC. Power it up. And you can see that is our AC waveform. It's not a perfect sine wave like I thought it would be for an AC output, but I don't know. This is one of the new CW80s that doesn't have the fan in it, which is really nice. I think they came out in like 2019. I love this thing, but yeah, this is its output. Compare that to like a post-war transformer, which I'm pretty sure is just a true sine wave output. But the number that we're looking at here is this VRMS. That's the number that you see when you look at it on a multimeter. What exactly that means, I don't know, but when you hook a multimeter on AC to AC track, and if I measured it right now, I'd get about 12 volts. So that's what that is. So what I'm going to do now is I'm going to power it down, and I'm going to flip my leads over to the DC positive and DC negative. I'm going to flip my oscilloscope to DC, power it up, and there's our DC waveform. Now, at first glance, this doesn't look too bad. The problem is, if we zoom out in our waveform here, you can see that it is not perfectly level all the way across. It kind of does this weird pulsing thing that you don't really want. So my guess is that the capacitor that I have is what fixes this issue. I know it does something with filtering, but I've honestly, even though I took a circuits class in college and we talked about filtering extensively and even used capacitors to filter out certain text in a signaled input, I really don't understand electrical filtering. So we're going to be learning together here. So I'm going to go grab that capacitor. I'm going to hook it up to this rectifier, and we're going to see how this output changes. So little disclaimer, capacitors are incredibly dangerous. They can hold a lot of voltage and they can hold it for a long time. So when these are energized, make sure that, or after you're done energizing them, that you either discharge them safely or like don't try to shock yourself with them, because you could make a pretty good taser out of one of these. So basically, I've got the capacitor hooked up, so this one's polar, so the negative is to negative and positive is to positive, as it should be. And if I put power to the track here, you can see our voltage shoots up immediately. This is minimal power being applied, and I'm at 16.5 volts. If I go up some more, right there is about our max voltage. Well, not on the transformer. That's about half voltage on the transformer, but we're at about 25, 26 volts, and it's not going any higher as I apply more voltage to it. But as you can see, our waveform is pretty well constant. So that's what filtering does, I guess, for capacitors. Which is neat. Okay. And if you're wondering why the buck converters are a thing, this is why. I think the max voltage that these boards are rated for is like 27 volts or something like that, which is pretty darn close, or maybe it's 28 volts or something. It's close to what this capacitor outputs. So the buck converter basically takes this input and just dials it down. So that's why that exists. That's why I'm going to be installing it, as well as the fact that I don't know where this engine's going to be run. And if it gets put on a layout that somehow gives more than, 26 volts and overloads something, I don't want that board to blow up. So I'd rather the buck converter blow up and fail than the Blunami board, because the buck converters are relatively cheap. I'm going to power down the transformer now, and you can see the other fun thing about capacitors, which is there's no real draw on this circuit. So this is going to take a while to discharge. Now you can expedite the process by bridging these terminals, which I will try to do and not make myself jump, but I will because it's going to arc really badly, so fair warning. There it goes. And you can see our voltage drop to 0. Yeah, so that just metallic joint across the poles bridges the capacitor, causes the capacitor to short, and immediately discharges the entire capacitor. So that's how you do that. Make sure you're using something insulated, because that could hurt. But yeah, so that capacitor is going to be permanently installed into this rectifier, and that is going to be directly hooked to my output, which is going to go into my buck converter. So I'm going to get that set up and in the locomotive, and we're going to go from there, probably with hooking up common lighting circuits and motor circuits. Real quick, here's my capacitor hookup method, pre me trimming anything. So I'm just running the AC lines underneath, and the DC lines are up top. So, and these are what will feed the Blunami board. Okay, progress has been made. The speakers are actually now hooked in, which is nice. Probably backwards, but I'll figure that out when I power it up. The capacitor and rectifier and buck converter assembly is in. It has its bus lines-ish. This is AC center rail, and this is AC ground. Goes into the rectifier assembly I showed you earlier, which is mounted directly to the end of the board. These are my outputs. I need to actually measure these and adjust this little dial here to about 18-ish volts, just because I think that's similar to what DCC systems run in HO. So that's what I'm going to try and set up here. And then right and left rail, now I could be wrong about this, but in my HO experience, it doesn't matter which one's positive and which one's negative. So the paperwork that I got with this thing has right rail as red and left rail as black, so I'm going to stick to that. I also need to attach the motors, but I'm going to get power set up first. And then I'll hook up my motors and then all the lighting. Okay, I got my multimeter alligator clipped up, set to DC voltage. Let's put some power on the track. Oh, it's set to like 20 volts right out of the gate. That's nice. So I should just be able to turn this screw. Yep. And my voltage starts dropping. So let's turn this down to about boom. How about that? All right. There's also a little red light on the board, which illuminates when it's got power, which is kind of cute. So as I change voltage here, you can see we are stuck at 18, which is perfect. And if I power it down, that's the capacitor doing its thing. So, very nice. Alright, now here's the fun part about me being the one making this video. Because I record on my phone, I can't control this engine and record at the same time. So, this is first startup. I'm going to show you guys what it does when you first put power on the track. I don't think it'll do anything until it gets connected to something, but let's find out. I was wrong. Man, that sounds good. So rather than, program the thing, which is what I should have done, I decided to just do the rest of the wiring. So all the lighting is now done. Headlight, backup light, number boards, and cab light, and right and left ditch. So all that's hooked up, and I have 2 inputs left. So I could do rear ditch lights if I had them, but I don't because it's an SD80MAC. And if you wanted to do rear number boards, you wouldn't be able to do them independently of the fronts. You just have to wire them into the same terminal that you're running the front lights into. This is all, I think, 22 gauge wire, by the way. I'm kind of proud of my wire management. There's a couple spots that I need to fix, but for the most part, I think it looks pretty decent. Most of the stuff's hidden. I have easy access to the board, and it looks pretty. So that's what really matters, right? But now I get to put this on the test track and actually program it, and I need to do a bunch of research and figure out what the prime mover was in this thing, what the horn was that the CSX bought them with, figure out what their bell was, and yeah, basically just try to get it as close to the prototype as possible, so when I give it to my friend, he has a pretty good slate to start messing with some of the sounds. But yeah, with that, let me go program this thing. Oh yeah, also I was able to maintain the original connectors, if you couldn't tell. So this is now completely separable. I can remove the shell from the frame and not have to cut any wires or unscrew any of the terminals. I just need to unplug 2 connectors and the frame is separated. So I did a whole bunch of testing, and first of all, this thing sounds incredible. I thought I was going to blow up this sound system because I have 4 ohms of resistance in my speakers, but it didn't seem to care at all. So that was pretty neat. Yeah, the prime mover sounds are insane. The startup sounds are really nice. All the horns that you can choose from, bells. Just for kicks, I listened to the EMD 645 Turbo prime mover, which I believe is what's in the SD40s and SD40-2s. And holy cow, it sounds like I'm standing right next to the thing. It's incredible. It's also very loud. It defaults to CV value of 225, which is max volume. I had it turned down to like 15 to do my testing because it's just ear-shatteringly loud. So if you like that kind of thing, there you go. But yeah, it's currently set to the 710G prime mover and a Nathan K5LA, just because that's what was equipped on the EMD SD80MACs. The bell I have, I believe, set to EMD2. I think that's just the default. It sounded the most like a road engine, in my opinion, so I just kind of left that as is. I didn't really touch many of the other sounds just because I don't know enough about them, nor do I really care that much, and I figure I'll let my friends play with the sounds and figure out what he likes. But I just wanted to get this so that it was close enough to the prototype so that it's got a good starting point. But I did learn that there are some issues with this, the main one being the thank you, brain, number boards. So if you remember that super weird bracket like up and over thing that I made for the number boards, they don't work. When you activate the number board function, it just turns off all the lights in the cab. It turns off the headlight and it turns off the cab light. So I think something is just either wired backwards or is just bridged. So when it's sending the voltage up through and into the number boards, if it's reversed, it will cancel out the voltage that's being sent to the cab light and the headlight, and it'll cause them to turn off. So I think that's how that works in theory. But yeah, so I'm going to dig into it a little bit here and see if I can figure out why that's happening and get it fixed. So I found the issue with the board. There's that bus wire that I had going across. When I put it back together, got crushed by the boss for the front screw that I neglected to take into account. Now, originally I had hit record and showed you guys fixing it, and then I looked over and realized it wasn't recording, so whoops. But that's fixed now, I think, I hope. But yeah, oh yeah, that actually like slid in. That's convenient. Programming. The hardest thing to program about this entire engine was the ditch lights, to be completely honest. The entire UI is very simple, very intuitive to use, and if you like CVs, if you're one of those people that's like, I need to be able to modify CVs, and I need to be able to like see what each value is, you can do that. And it's nice because unlike NCE, which is a system that I'm familiar with, you don't have to go through CVs one by one to figure out what their values are. It just shows you on the app. And again, the UI is very intuitive, which is nice. But yeah, so ditch lights, I got lucky and I ran them into functions 7 and 8, not thinking anything of it. And turns out functions 7 and 8 in the Blunami app are linked, so you cannot activate function 7 independently. When you activate function 8, it turns on function 7 and 8. So that's really convenient for ditch lights because it means when you activate function 8, it turns on both ditch lights, because the ditch lights have to be on independent functions to be able to control left and right sides, because they alternate. Speaking of alternation, when you set up the lighting, you need to make sure that one of them, it doesn't matter which, is set to phase B instead of phase A, which is the opposite polarity. Basically what that does is as the signal is being sent to the ditch lights to pulse, one of them is inverted, and that lets them switch. Otherwise, they turn on and off at the same time. Currently, I have it set to ditch light type 2. I am not sure what the difference is between type 1 and type 2. It exists. I'm sure somebody out there knows. I am not aware of it. So, temporary pause. I need to remember which way this goes. I have a cooked LED. Nice. Get some soldering. Yeah, you can also change the rate that the ditch lights flash by changing the hyper flash, I think it's what it's called, number. I changed it to 5. That gave me, it defaults to 3, which just looks a little too fast for me. I set it to 5, which I think is about right. Again, I wish I could show you, but I can't record and use the Blunami app at the same time, which is irritating. So yeah, that was how I set up the ditch lights. The other really nice thing about this is that when you're setting up lighting, you can choose between incandescent and LED. So I'm guessing what that does, I haven't measured it, but I'm guessing incandescent sends like approximately 12-ish volts to your lighting, whereas LED sends about 3. I have everything wired for incandescent voltage, but I have everything set to LED. Now, you have to be careful with that, because you can set, if you're going to use the LED setting, you can wire all your lighting up so that you don't have resistors and you're planning to use the LED setting. However, all of the lighting defaults to incandescent. So you have to make sure that before you turn on any lights that you've wired up with no resistors in line, that you switch all of your lighting functions over to LED. Otherwise, you will blow up all your lighting, because it immediately sends incandescent the second you hit that function button, unless you've changed it. So yeah, just a note there about the lighting. But there are a bunch of different lighting types that you can use, so that there's pretty much something for everything. You can do Mars light, you can do beacon light, you can do firebox, flicker. There's a lot. So endless customization. The only thing I haven't figured out how to do yet is Rule 17 lighting. I can't figure out how to make the cab light turn off when the engine starts moving forward, and the headlight get brighter when the engine starts moving forward, and the backup light get brighter when the engine starts moving backwards. So I haven't figured out how to do that yet. There's probably a way to do it. I'm just too new with this to know how that works. But yeah, that's the only thing that I'm kind of stuck on. But I have all the lighting set to just be able to be turned on and off anyway, so it doesn't really matter. You can just do it manually. I also have the digital lights, going back to that, I have them set to turn off in reverse because I think that's how it works. I'm sure somebody who knows more about modern diesels can tell me in the comments, but I'm pretty sure the digital lights are turned off when the engine is going backwards because, at least for this engine, doesn't have rear digital lights, so there's no point for them to be on, right? Again, somebody correct me if I'm wrong in the comments, but I think that's how it works, so that's how they're set up. Because you can change the lighting to be either on or off depending on if the engine is in forward or reverse, which is really only applicable, I think, for ditch lights and headlights, and maybe number boards if you have independent number boards, but other than that, I'm not too sure what it would be used for. But long story short, you can do tons and tons of stuff with this, and it's way more versatile than any O-gauge system I've seen, especially with like the level of detail that you can go into with literally everything. So absolutely fantastic system. I'm actually now considering buying a lot more broken engines to put this stuff in it. It's just a matter of, can I buy the broken engine for $200 less, or $200 plus the rest of the hardware, $200 plus that less than a fixed one? That's the only way that the money makes sense. But regardless, this is definitely something I'm going to be using more in the future. Even, like, I'm not a big diesel guy, and that sounds incredible. And I love what you can do with it. So, anyway, I'm going to keep playing with this lights because I'm distracted by chatting about how awesome this thing is. I'm going to see if I can get this fixed, and yeah, I guess the next time you see it will hopefully be when I've figured out how to record this thing while also being able to control it so that you can see what it does. But yeah, I'll see you guys then. Okay, we're back. I have stolen my fiance's phone because her iPad wouldn't download the app, so this is what we're doing. Let's power it up, start it up. I have the volume turned down a little bit just because this thing is obnoxiously loud. I'll select the engine here. I've already got most of the stuff configured, but I haven't redone the lighting inputs yet. For some reason, so I programmed everything on my phone, which is Samsung, and when you view the app on an iOS system, it has a completely different UI. Well, I mean, it's similar, but like, it's different enough that I have to go back through and reprogram it all. But you can also tell that the system was 100% designed on iOS because there's a couple weird quirks about using Android that don't exist on this. Anyway, so really simple. I can turn on and off my headlight, bell, short horn, long horn, which can also be used as a short horn. You have your forward and reverse selection here. Loco stop is just basically if you hit the direction key on a cab 1, or like hit the 0 function to reset it, that's what that would do. So if you open up the little, it's a sound icon, I think it's a function button, I think, on Android down here. You press that, and you can see your function 0 to 28. It shows you 0 to 14 first. You see you have headlight. For some reason, short horn was on. you know, bell. You can actually, if you hit RPM down, you can shut it down, but I'll do that later. You can mute it if you want to, you know, actually have a conversation with somebody. The dimmer setting is there. I don't really know what that does. Straight to 8, that's mostly sound settings. The second page is where all the fun stuff is. You have like the cab chatter and whatnot, and then these are your function keys. So function 8, which for some reason was on even though my ditch lights weren't. So function 7/function 8 are my ditch lights. Function 3 is my cab light, and function 4 is my number boards. And currently they're all set to, or the cab light and the number boards are set to diesel light, which has a sort of fade in and fade out, which I like. So with the ditch lights on, I should be able, hopefully you guys can see it, if I blow the horn, you can see the ditch lights start flashing. And again, that's set to like about 5, I think, on the hyper flash. If you want to change any of your settings, if you click the little settings icon, you get a whole bunch of stuff. You can set your DCC address, which doesn't really matter too much for our application since we're just running it with Bluetooth, but I set it to 772 because normally on DCC you just set it to whatever your cab number is, or your locomotive number is. You can set your nickname. I set it to CSX 772 because that's what it is. And then you can go through and you can go through your sound settings. You can adjust all your volumes, so your master volume. In your main sounds, you can select your prime mover, so I have it set to the 710 because the 710G, the T2, sounds too new for me. I don't really like how aggressive it is. So you can select your horn, and again, there's a million different horns that you can pick from. The one I think most people are probably going to be familiar with, I think, is the K5LH. Yeah, and then you can hit a little horn icon to test it sometimes. It also likes to freeze up occasionally. Yeah, there you go. Okay, you get the idea. It's the that's the Jibo horn. So I have K5LA2, you can set your bell, there's a couple different bells, everything from Alco, EMD, Fairbanks Morse, GE, and then a whole bunch of others. So, very nice. In your lighting settings, this is, sorry, I'm doing a terrible job showing you guys this. You can set your brightnesses for various brightness level, or brightness settings that you can select in your actual like function configuration. So for headlight, again, this is going to be wrong because I haven't configured any of this. I think normally it's, or I think you can set it to, what I actually eventually had it set to is auto dim reverse. For some reason is the one that makes the headlight get brighter when it goes forward. And again, you can set it to incandescent or LED. Yeah, my headlights are still on. And now if I start moving, it gets brighter. And then when I stop it, it gets dim again. So, a whole bunch of lighting stuff you can do. I'll show you some of the other things that are in here. So on-off output, disable or dimmable, different types of Mars light, strobe lights. There's your ditch light types. That you can do a Fred. There's an engine exhaust flicker, which it only flickers when your engine starts moving, but I think it's supposed to resemble like sort of flames or something in the exhaust stack of a diesel engine. On-off brightness, ash pan, firebox flickers in here. And then this is your phases that I was talking about for the ditch lights, where you can set phase A or phase B. One ditch light needs to be on A, one ditch light needs to be on B. But yeah, and again, whole bunch of settings that you can go through, but in the end, it is pretty much guaranteed that you will find some configuration that you like. And it does do brake squeal if you have the momentum set right. Also, speed step 1 on this thing is a crawl. Right now, the front motor isn't even spinning. It's getting voltage, but it's just not spinning. The rear set is, though. But it uses back EMF, so it has cruise, where speed step 1, it will put enough voltage to the motor to make this thing crawl, and you can calibrate it and whatnot. It has dynamic exhaust, too, so like if I speed this up and put a bunch of load or drag on the wheels, you can hear it idle up, let it go, and it idles back down. So, but yeah. See if I can get it to shut down here. So yeah, so very, very cool system. Lots of options. And yeah, you can program pretty much anything you want with this thing. So hopefully I'll be able to get some shots of this thing running on the club layout this weekend. But if not, there you go. So there you have it. That was my Blunami upgrade for this Lionel / K-Line SD80MAC. And I'm not one for modern diesels, but holy smokes, the sound that this thing makes. I have a fantasy railroad that has a GP40, and if I ever get that model, 100% I'm buying a broken one and putting Blunami in it, because I don't know of any sounds that can compare with that are in the Legacy 3-rail world. So if you are a fan of customizing engines and you like going in and configuring everything, definitely add Blunami to your list of considerations when you are looking at upgrade options. If you like the tried and true plug and play nature of the electric railroad, stick to that. There's no real there's a little bit of configuration. The configuration's a lot harder, but for the most part, the electric railroad boards are very simple, and they're pretty durable electronics. I don't foresee having any major issues with them, at least in the coming years. But this board, while the Blunami boards themselves are really only 3 years old, they came out in 2022. Soundtrax has always had a history of making very durable DCC decoders, and I don't foresee these being any different, especially with voltage regulation that's cutting down your voltage from near max, which is what this would have without the buck converter. I think those boards are going to last forever. Going forward, I do want to experiment with different capacitors on that rectifier. I want to see if I can bring down that voltage bump that the 1000 microfarad capacitor generates. I think that a smaller capacitor would probably bring down that voltage a bunch, but I'm not sure, and I don't want to experiment on this engine because it's not mine. So whenever I do get an engine that I'm going to be putting Blunami in, I will be sure to test out different capacitors, probably like 800 microfarad or 470 microfarad or something like that, just to see what it does. But for now, that's going to do it for this engine. So I hope you all learned something from this, and maybe now you'll consider Blunami for one of your upgrades. And if you want to see what these boards are truly capable of, again, go check out Sid's Trains. He does incredible stuff with this, and he's figured out some crazy features you can add using the function outputs. But yeah, definitely go check out his stuff if you're interested in anything that has happened in this video. But anyway, I hope you all enjoyed. I hope you all learned something. I'm CW Hollow 1, and have a good day, or maybe good night in your case. See ya.